All right. So, hello everyone. Welcome. This is week 6 of our, I believe, 8-week series on basically building an app with Cassandra, a cloud native application. This week has me super excited. This is where we actually start to get cloud native with it. We're basically taking everything we've done so far and we're saying, hey, how do we actually do this with containers and Kubernetes and all those good things that actually make it kind of a modern application. So super excited today. Hopefully you guys can all get some good info out of this, and then of course we will have all of the homework and everything as well. So a little bit of housekeeping before we get started. I'm joined today by the team. Basically everyone you see here. We got a bunch of advocates. We got some community people. And as you can see, we're all global, everywhere from the US, UK, Australia, and even France and Germany.
Yeah.
Oh, well, yeah, he's in Germany, but it's got the Russian flag there.
You can
He's
tell.
from Russia. So. All right. So, my name is Erick ZIETLOW. I'm right there, Erick ZIETLOW from America, and I'm joined here today by Cedric. Say hi, Cedric.
Hi, I'm pretty happy to be here with you.
Yeah, awesome.
With a packed session again today.
Yeah, we'll see if we can get through it. I'll try to be on time for y'all this week. We'll try to make it through the content. One thing I will mention is if you want to stick around after the session, we'll take a 5-minute break at the end, and then we'll actually come back on and kind of have a bit of a Ask Me Anything session for probably about a half an hour or so after the session. So feel free to stick around, ask questions, get some info, just sit around and chat with us. It's all good. So, all right. So, week 6, our app in Kubernetes. Last week we covered Cassandra in Kubernetes. Now we're kind of putting it all together and we're spinning up this entire thing in Kubernetes. So we're going to do some Cassandra, we're going to do our application, and it's all going to be, in Kubernetes running. So really, really cool stuff. All right. Housekeeping. Lots of things you're going to want to have available. One of them is the live stream. You're either watching this on probably Twitch or YouTube. We get by far more viewers on YouTube than we do on Twitch, but they are both there and available for you. We have our Discord, which we can post the links for the Discord in the chat right now. Discord is basically a place where you can interact with us, especially throughout the week when we're off of the live stream or offline. We are accessible on Discord. Highly recommend you check that out. And of course, comments in the chat windows on either Twitch or YouTube. We can also interact with you there. Materials are all up on GitHub, and we'll cover that kind of as we're going through the live hands-on portion. But the GitHub has everything from all of the weeks. It's all pretty easy to navigate. It's all right there at your fingertips. So highly suggest checking that out.
I do have a couple of words here, if you don't mind, Eric. So first, last week we know that we asked you to run pretty heavy process and workload. So if you were running on your laptop, sorry about that. It was a lot of resources needed, like 8 GB of RAM and a lot of stuff to download. So don't worry, today it will be less demanding, less resource consuming.
Yeah, and just another note on that, different from last week, we're not going to actually have you guys work the hands-on portion along with me. I'm going to work the hands-on portion and interact with you guys, and then we'll actually give you cloud instances if you need them, or if you have the laptops, you can do the homework portion. We're assigning it to you as homework instead of kind of do it along with me here. So
yes, exactly. So last week we tried to just postpone cloud instance provisioning just for you to see what's going on instead of trying to understand all the commands. And we feel that it works very well. So here you can totally attend what we are doing, and later during the week do the exercise.
Exactly. Awesome. So with that, one last thing I'll cover here is DataStax community. Highly recommend you check that out. That is another way you can interact with us. We got Erick Ramirez on there all the time giving answers. Bettina is also, just an absolute champion on that. So check it out. If you haven't seen it, ask questions, get involved, and let us know what you think of these sessions. We love feedback. We love talking about these things to you guys. So hit us up. All right. We have a Menti. I'm going to pass it off here.
Yes.
Cedric, take it away.
Yes, you do. And, speaking of Menti and just pausing here, I will wait you to be ready. Just please thumb up. So today we're doing the 2-hour session as usual, and we will do a pause, 5-minute pause, and then we will be together again for 30 minutes if you want. And this is Ask Me Anything question, okay? Me and Eric reading all your questions on Discord and on YouTube, trying to figure this out as much as we can, okay? We try that today, something new. Let's see how it goes.
Awesome. All right, so we're going to dive right into it here. There's going to be a bunch of review from the last couple of weeks. That's okay. We'll blow through it real quickly, and then we'll get into that kind of hands-on live demo portion of this. So just stick with me through this, and we'll get there. All right, so quick recap. Containers versus virtual machines. Containers are essentially a very similar concept, but they don't have their own OS. They aren't running their whole, it's not a whole computer in a box. It is a bit of a computer, what you need to actually run your application. It essentially allows you to have a much lighter resource, I guess call it entity, but still keep things separated and keep nice buckets to store everything in, keep it all nice and clean. So containers are a good thing. Docker is used for a lot of container management these days. Docker is kind of the one that everyone has heard of, or most people have heard of. There are other things out there, but by and large, Docker is the big one on the block. Images versus containers, we're actually going to work with both of those today, so I'm not going to dive too deep into that here, but just understand that images are basically the template, and a container is the actual object itself. It's the thing that is running that you are doing things with. All right. So Docker commands, you should be pretty familiar with these at this point. We are going to be using Docker build today. We're not going to use Docker run. We are going to talk about Docker run because it is basically the way you would actually run a Docker container inside of Docker. We're actually going to be running Docker containers inside of Kubernetes today. So that's kind of where we're going to diverge a little bit. And then there's a lot of other things you can do with Docker as well. All right. So applications and containers, essentially, the container itself is like a application in one sense. From the operating system standpoint. It's a thing that lives within your operating system on the host machine. It gets to take resources from the host machine. It gets to use different parts of the host machine to do its thing, but essentially it is this little self-contained application that's running in its own little environment out on your machine. Cassandra and Docker, this was last week. Got a couple slides here on this one. Wasn't actually very hard to set up once you understood what was going on, and you'll even see when we get into the hands-on portion, we're going to set it up again, but it's going to be really, really quick. It's going to be like, a slide and a half. Not going to take long at all. Basically, once you get a couple config values down, you can just spin this guy right up and you're good to go. All right. Kubernetes. What is Kubernetes? Kubernetes is that thing that allows us to manage a wide variety of resources across multiple actual servers as a resource pool and run our containers in that resource pool. Really, really useful. It also does a lot of provisioning stuff. It allows you to do scaling. It has some self-healing features. And then there's a whole bunch of service discovery stuff that it can do as well. It's really, really cool, and it takes a lot of those, what historically have been more complex operations problems, and it puts them into a very manageable context for us to work with. So really, really cool tool, and we'll be taking advantage of that here today. Okay, Kubernetes infrastructure, we have our control plane. This is basically the thing that manages our Kubernetes cluster. We have our worker nodes. The worker nodes are essentially the things that are actually running the stuff. So that's where our app is going to live. That's where our Cassandra is going to live. It's all going to live out on the worker nodes. Today, we're only going to do an example using kind, and we're going to have a single worker node just so that we can basically not overload anyone's laptop. But if we wanted to, we could go out there and have 100 worker nodes, and they would all be managed by the Kubernetes control plane. All right. So I'm not going to dive too deep into this one, but basically just understand that Kubernetes is not just a single piece. It's not just a single thing. It actually is made up of a lot of building blocks itself. It's got etcd for its backend store. It's got a scheduler, of course, a controller manager, and then it's actually got an API server, the REST API server, and then I believe kubectl is also connected in there to let us interact. Okay, we've got a whole bunch of terms here. The main one I'm going to be using today is actually pod. We've covered all this before. Pods are basically what we're going to be spinning up in our Kubernetes, and these pods will contain our application or the various parts of our application, and we'll actually go through and view some of those while they're running and view what kind of they look like.
Yeah.
The other thing we're going to be using a lot of today is the namespace. Now, again, we covered this last week, but a namespace, just for a quick recap, is basically a container that you store different pods in. It's a way to differentiate different things that you're running. So this week, we're actually going to be running our Cassandra over in one namespace and our application in another namespace. And we'll show you what that looks like. But essentially, it's a way to divide those two pieces up into their own little safe sections, and we can interact between them.
Yes, and it's all logical. Nothing to do about the infrastructures. The namespace run across multiple workers. Don't think about that. But the best practice is having a namespace for each application. This is what we will do.
Yeah, I see a comment here. Namespace is like a virtual subnet. Kind of, if we think of it in a non-networking term, yeah. It's basically a different set of buckets, just like a subnet would be. It's a different set of buckets that you can store different things in and keep track of those buckets. So, yeah, that's actually kind of a good analogy. Okay, so we have storage. Now, this, again, is from last week where we were talking about storage classes and how you don't want ephemeral storage and non-persistent storage if you're storing stuff in a database. Now, for our application, that's totally fine because we aren't actually storing any local data. We are doing database requests, and that's all being stored in our database. So we don't have to worry so much about creating persistent volumes or anything like that because it's not something we're really going to deal with. Essentially, our containers are running in RAM. So if they go away, that's fine. We spin up another one, and they have access to the database with all the same data we were using. So really, really good thing to know. Not going to affect us too much today, but it is there. So just understand it. All right.
Yeah, just we did a good question about storage. Yeah. We tend to say to get better performance with Cassandra, you need to use local attached disk. Don't leverage on SAN or any replication. Let Cassandra do the replication for you. Well, in cloud providers, you will see multiple storage classes, and some storage classes are really, pretty fast. SSD maybe not attached, but that's still pretty, pretty good for workloads. So we are not really afraid about running high workload against Kubernetes. You will scale out anyway.
Right. That's an excellent point. Yeah, and the whole thing, Cassandra and SAN has been a topic I think since day one of Cassandra's existence. There's a ton of blog posts and stuff on that. If you're ever curious about why that's a bad idea, bring it up in the AMA if anyone wants to hear it. We can dive in, or there's blog posts if you want to go search those out yourself. But it's kind of an interesting topic. Okay, so this basically is what our Cassandra setup is going to look like.
Yeah, this is what we did last week.
Yes.
And yeah, just because everything that you show will be just a small piece of the schema later on, and you will recognize what we are doing.
Right. And all of this is basically going to be obfuscated today under, I think it's like 5 different commands. And it will just do all of
and we are doing single node, okay? We don't want to crush your laptops today.
Right, absolutely.
And no Prometheus, neither Grafana. So see, the big stuff is now on the top hand corner. Cass operator is its own namespace. And today, with the namespace my app, we will create pod for backend, frontend, expose port, and provide a config.
Yes, and all of that, we'll run through all those files, what that all looks like, but essentially, from the person who's managing this standpoint, we want it to just be a list of a few commands they have to run to scale this or to update this or to kind of make any change here. Should be very, very easy for them, kind of taking most of the operations out of that and letting Kubernetes do the heavy lifting for us. So, okay, if we were to go out and we were to build this out and deploy it in a production environment, it would probably look something like this, with our application having multiple instances. We'd have a load balancer in front of that. We'd have the Cassandra out there. We kind of have this huge, huge construct. You're probably not going to be able to run that on your laptop. So what we're actually going to do today is a little bit easier than that. If you did want to connect this to Astra, it would look something along these lines, where we have our application running and you can have your connection going out to Astra. And I'll cover how you can do that. I'm not going to do this today, but I did want to bring it up just so you guys can be thinking about it. And then what we're going to do today is we're going to set it up so that both the Cassandra and the app are running in Kubernetes. And you know what? I just realized with this slide, we should have put nice little namespace boxes around these so that we could see more clearly how things are differentiated. But essentially, it's just 2 namespaces, and we're actually going to be running our Cassandra right next to where our application is running. All right. So what you're going to need to actually do this is your laptop or a cloud instance. Now, as we said before, please don't do these exercises while I'm doing them. Please interact, ask questions, be involved, while I'm doing the exercises and showing you on screen. But if you're trying to work along with us, you're probably going to get less out of it. So please, that's your homework for this time, is to go out and do what you see here today. So I believe we have a cloud, is it a cloud instance registration form if you need one of those? Is that correct, Cedric?
Yep, exactly. So below the video, there is a form to request a cloud instance, and we will launch all the provisioning, let's say tomorrow morning.
Perfect. Wonderful. And then you'll be able to use those to do everything you've seen here. Okay, now we're getting into it. So I'm going to run through the slides, show you all the commands, kind of talk about them a little bit, not going to dive in too deep, but just kind of give you a little bit of a precursor, and then we're actually going to get hands-on and we're going to do it. So let's get to it. All right, so running your application right now, you basically have to do something along these lines, where you go in, you're going to set up your env file, you're going to do your install, you run start for your UI, and then depending on if you're doing Python or Java, there's a list of commands you'd have to run to actually get this application running. That's basically running on bare metal. There's no containerization, there's nothing special going on. It's just, hey, look, I have an application running, there's, here's where the UI is, here's where the backend is, it's all talking, it's working. Now, if we simplify this with Docker and Kubernetes, it's going to look more complex, but what's actually going on from a management standpoint, once it's all set up, is going to be very, very easy. And you'll see that when we actually just kind of boil it down. It ends up being a very short list of commands you have to run to get this whole thing, deprovision, provision, scaled, updated. It's just super, super simple. So we're going to get into that. All right. Docker files. Docker files are essentially the template instructions for your container. They are what your, if you're using Docker or if we're doing the Kubernetes they are using these Docker files to determine how is this thing being built. What is it going to be running? What are the dependencies it needs? What is the environment it needs? Notice, like right there in the Python, we have that very first line from Python Alpine 3.7. It's setting up the Python environment for us. We aren't having to go out and do that, do all our configuration, get that running. It just does that. It's a Python environment is what this will be running in, and it understands that. We set up our working directories right there with the copy in the working directory. And then you can even see we're running our pip install off our requirements.txt, exposing our port, and we're basically good to go. And I just realized I got ahead of myself here. So picking apart the Python Docker file. So again, setting up our environment, setting up our work directories, running our dependencies, exposing our ports, and actually running the application. So basically command, Python, boom, calling whatever that entry point was, which in this case is our getting started with Astra.py file, and our application is up and running. Okay, how do we do that? Well, it's quite simple. We run a sudo docker build, and what that does is that takes that Docker file and it creates an image. And that image, if you remember, we mentioned this before, is a template. It's an instruction set that can be consumed to create a container. So we're going out and we're building that image. Then we do a Docker run, and that will basically take that image and it will turn it into a container. It will use it to build a container. So really, really good to understand the difference between an image and a container. The building of the container uses the image, and the building of the image uses the Docker file. It's just a nice little progression. Okay, so we have that up and running. Great. But what about Kubernetes? We said we were going to do Kubernetes. Yes. Okay, so if we had our Docker running our containers, that's on one box. That's not really across multiple servers. That's not, a really cloud native solution. That's simply living on some box somewhere and running these little containers in this box. But what if we have this gigantic resource pool, and that's what we're actually trying to run our application on? So we have, say, like 100 servers up in AWS, and we're trying to do an at-scale production application. Well, this is where Kubernetes shines, because we can set up everything as a giant Kubernetes resource pool and use what we need to spin up our apps and scale things accordingly. All right, so to get basically last week up and running, and you're going to see, I said it was super simple, it's these commands. Literally all we're going to do today to get our Kubernetes up and running is this small set of commands. You guys believe it took us 2 hours to cover these commands last week?
Yeah.
But now, hopefully, having gone through that, you understand what they're actually doing. I'll touch on it very briefly, but I'm not gonna. If you're curious, go watch week 5. It's all there. It's good content, and it should explain pretty much everything here.
Yeah,
we're boiling it down.
We do have time. We can go back and explain things. And for non-native English speaker, we will, slow down, try to speak not too fast. Sometimes we just rush everything. Let's go for it.
Too quickly. Okay, yeah, I'll try to slow it down a little bit.
Oh, you pick my little dark secret message in there, right?
Sorry, I get excited about this stuff. I talk fast.
Oh, back to this slide. Okay.
Yes,
we did that last week.
Just showing you. See, there's our configuration, and what that sets up again is this right here. What you see, we got our nodes, we got all of our Cassandra configuration, we've got all of that stuff that you need to make the Cassandra cluster run. We've now condensed down into like 6 commands. So really, really cool. All right. Building and loading your Docker images. Now we talked about Docker build. Docker build is still a step here. We still need to take that Docker file and build out our images. And then what you see here, what you see here is that the last 2 lines, the kind load Docker image, it's literally going out, it's grabbing that Docker image, and it's putting it into our Kubernetes. Now, you'll notice the Docker build lines, they both have this -t, and then they have that astra-ui:/my image. We are tagging those images with an identifier that kind can take and use to pull that image. So you see, we're actually calling that tag when we do the kind load Docker image, and then we have that that tag listed out. And that's how we're kind of doing the handoffs here, is all by these tags. So really, really important. If you did just a Docker build and you did put that -t on the end, it would actually work. It wouldn't error out on you, but you couldn't then just go and take kind, load Docker image, and load that image. So make sure you're taking your images. Make sure you don't miss that step. It's critical.
Yes.
Okay.
So with Docker, you build the image. So remember, this is a template. So the template is now on your machine. And what you want to upload the image where kind can find it. This is what we call a Docker registry. And the most famous is Docker Hub, but yeah, we won't download from Docker Hub. We are creating something custom. So Docker build, create custom image for your app locally, and kind load, upload those image to the kind cluster. So it can take a bit of time, depending on how much library you need to make your app running. So for instance, the Java backend is a Spring Boot application with a lot of dependencies. The image we are creating is about 700 megabytes. So it takes a few seconds, maybe minutes, to make this image upload into the kind. And when it's in kind, it's pretty easy to start up from the instantiate the image to create containers.
Absolutely. And it's important to note here, one of the nice things about us creating these local images is then we don't have to wait for the network to catch up when we actually go and do our stuff here, because we don't have to pull from Docker Hub.
So. We eat enough your networks, I guess.
Yeah. You can thank us later.
Yeah.
All right. Then what we're going to do after we've set up, we've loaded those into kind, we actually have some configuration to do. Now, this is all very kind of meat and potatoes for this week. This is stuff that we've got to, we really need to understand what's going on here. So the first command that you see there, the kubectl get secret, and then we have this, super user, and the namespace -n is always namespace in Kubernetes. So we're going to Cass operator namespace, which is the one we're running Cassandra in, and then we're basically spitting out a YAML. What we're doing there is we're actually trying to get the operating password for the database, because we need to be able to connect to this database, and since this database actually spins up a pretty much randomized password, we need to be able to retrieve that. So that's going to actually spit out a very long file, but the part we care about is that data tag, and then obviously we see password and username in there. For the more astute of you, you might notice that looks a whole lot like a base64 encoded string, and you would be entirely correct, which means the next step is going to be basically decoding that string, and that will spit out our password. So we're going to use the command right here with obviously base64 -d, and then we will get our string back.
Yes.
Okay.
And depending on the base64 version command line, somebody told us sometimes you need to do -D. But yeah.
Yes, and I'll actually run into that today when I'm doing the command, because I believe it's the version of base64
yes.
I'm running on my Mac is looking for the capital versus the lowercase. So we'll definitely hit that today. Okay.
Yes.
So,
all right.
Then what we do is we got to set up our schema, because a database is no good if we can't use it. So we're going to go in to the actual Kubernetes node. You can see there the kubectl exec, and then we're actually going to go into a bash terminal, just like you would on any Linux box. Should feel exactly the same, and you see there at the end of the command the bin bash. That's basically what we're saying is give me a bash terminal. And then we're going to CQLSH in, and we're just going to straight up paste our schema into CQLSH. Because why not? We can do that. We could also write something to do it for us, but there's really no point. We can do it very easily by hand. All right. So all this comes together in the configmap.yaml. The configmap.yaml is basically the file that says, here's all of our configuration. Here are all of these things that are environmental variables, all of these individual values that our application is going to need to run the way we want it to run. So your configmap.yaml may not look the same as my configmap.yaml, and it probably won't, because your database password will be different. You might have named your key space something else, or your connection points almost certainly aren't going to be the same, although we'll get into kind of a cool little thing we can do with connection points in a few minutes here. The one thing I really would like to point out to you guys is you notice that use Astra value there, we've set it to false for today. So if you wanted to go through and you wanted to set this all up and use Astra kind of like we have in previous weeks, you could just change that to true, and then most of the other values that are in that file you wouldn't actually need to put there, because they will just, it'll just not look for them. It'll use Astra. You do that whole drop your secure connect bundle into the UI thing that we've done a few times already, and it's good to go. But for this week, since we're doing everything local, we're changing that to false, and then we got to fill out our connection points and usernames and passwords and all that stuff. So, okay. So at this point, what we have is we basically have two namespaces, and we have our configuration. Now, we don't have our app up and running. We don't have any other pods living in this namespace. We just have this configuration in this namespace that is saying, hey, I'm a config. I'm available for any pods that need me. And we'll get into how we connect those pods to that config here. All right. So then we have two YAMLs. We have the backend YAML and the UI YAML. Now, the backend is obviously our backend. That's the Java or the Python process that we've done in previous weeks. And when we go and we build that Docker, or we do the Docker build command, you'll notice that under containers and the image, we have that tag. We're basically pulling that by tag, and it's linking up with the YAML there. We've also exposed our ports. So we don't have to do that manually in our process here. We're going to expose some ports from kind out, but these ports on these images are actually being set up in the YAML here. And then at the very, very bottom, this is kind of a secret sauce sort of thing, but not really secret. We have our env from, and we're referencing our config map. If you remember, we named our config map. Actually, I'm going to go up to it just so we can see. Under name, we named it env-config, and we're referencing that. And since we're spinning these up in the same namespace, they're going to be able to see that. It's going to be available to them, and they're going to pull everything we had listed out there in its variables. They're going to pull those all as environmental variables for those containers. So super, super cool, super powerful when you're actually trying to run this app maybe in different environments or maybe with different backends or however it is you want to do it. Super, super powerful there. Okay. Then, Then what we have is a namespace. We now have our config, we have our backend running, and we have our Astra UI running. So everything we need to have a working app is now in this namespace. Pretty cool. And it was only basically 3 configuration files we had to set up to do that. All right. When we actually create that namespace, it's a really simple command. It's the kubectl create ns, or namespace, my app. And then you'll notice all of our following commands where we're applying these YAMLs, we're doing that -n my app that's saying, use this namespace and apply that, the config map.yaml, the UI, and the backend.yamls. We're just going to apply them in that namespace, and Kubernetes knows what to do with them. It actually goes out and spins up all the resources and spins up everything it needs to have those things running. And we didn't have to do any of that configuration. It just does it for us. Again, Kubernetes makes life simple, not more complex.
Yes, and in the YAML file, we did not define the namespace. And as there is no namespace in the YAML, we can deploy these resources. So in Kubernetes, we talk about resources in any namespace. So these commands say, please deploy everything you find in config-mac.yaml into the namespace my app.
Yeah, so we don't have to call it my app. We could call it, pretty much anything we want, as long as we do the create the namespace and then we reference that, that same name in our commands when we're actually applying things. Absolutely. Okay. Last step is going to be forwarding our ports, and this is literally just saying, hey, namespace my app, we got to forward some ports open so we can hit them from the outside. our browser, we're actually going to go in and we're going to hit both of these once we're done, and you're going to see the backend running, you're going to see the UI running. Boom, good to go. Awesome. All right, so now we get to go in and we actually get to do what we just talked about. If I'm talking too fast, slow me down, guys.
I will.
Super exciting. Yeah, right. All right, so I'm going to go over here to my IDE. Now, what you're going to need, if you haven't already done it, you're going to want to git pull everything from this week. So just most of you have downloaded this repo at some point. Git checkout. Just do a git pull and get everything current, because we were literally making changes up to the last minute to make sure it was the best content possible. So make sure.
What a disclaimer! I don't want to watch you anymore now.
Right.
Okay, so demo mode
awesome.
with last minute edits. Totally fine.
Yeah.
With 374 people watching. So yeah, good luck.
Yeah, so they'll get to laugh at me if I mess up. All right, so we're going to go into week 6 here, and you're going to notice we have, actually I should expand this so you guys can see it a little bit. Is that big enough for everyone there? Can they all see it all right? Just one in YouTube comments, let me know.
For me, it looks big enough, but waiting for people to just see if the font is big enough.
Okay, yeah. Well, I'm not seeing anyone in YouTube complaining about it, so it looks good. Okay, yeah, we should be good.
Yeah.
All right.
Okay, looks good. We got legs good. Let's working like Java. Everything is good until you got an exception.
Right. All right, so we're going to have the Java backend here, which has its own folder. We're going to have the Python backend here, which also has its own folder. And then we have the UI, which, again, its own folder. You'll notice there's a sneaky little other folder in here called cube files, which wasn't there in previous weeks. This has all of our Kubernetes YAMLs in it. Everything we need for our Cassandra, everything we need for our application. And these are what we're going to be editing today to make the Kubernetes work the way we want it to. So you'll notice they've got numbers on the front. These are steps. So you start with 1, move to 2, 3, 4, 5, 6, 7, and we have our app. So basically 7 steps, right? There's a little more to it than that. All right, so let's go over. If you're looking at the GitHub, you're going to want to be in the DataStax Academy Cassandra Workshop series GitHub, and then go down to the week 6 apps in Kubernetes folder. We're going to go ahead and click on that. Now, the README here has all of the instructions, and that's what we're going to be using today to go through each of the steps. So you can read along with me, or you can just watch. But again, please don't actually do the exercises while I'm doing them, because you'll be asking questions, and we'll try to make this a little more interactive, and you can do this as your homework. All right. So first things first, we actually have to get into our working directory. Since all of our YAMLs were in the kube files directory, I'm just going to start there. It's kind of an easy starting point. You don't necessarily have to be in this folder to call any of the YAMLs, but it's just a much shorter command for me to type instead of having to type out a full path.
I do have a question for you, Eric. Is it Gitpod or your environment? That's totally look like Gitpod.
Oh, that's actually an excellent question. So I am actually using VS Code, and yes, you are 100% correct. It looks like Gitpod. I think they actually use very similar elements. I think it might actually be Material UI or something.
It's totally the same. Yeah, I missed some color, but except from that, quite the same.
Yeah, and it functions very similar as well. There's not a lot of difference, but yes, this is Visual Studio Code. This is actually on my local box, and at the end here, when my fans are going at 100% and my box is crying and weeping from all the things I'm trying to run on it, you'll notice that a couple of the commands will get very, very slow. So,
so that's definitively your laptop, right?
Definitely my laptop. Yep. All right. So we're in our kube files directory. I was bad, and before I got on, I had already navigated there. So I'm sorry for that to anyone who noticed the error there with the
no such file or directory. Yeah.
All right, so we got to go ahead and we got to create our cluster. Now this literally is, I'm going to talk about it while I'm running the command. This literally is going out there and it's provisioning resources, or I should say, it's taking the resources that are provisioned for it, and it's creating this pool. It's creating all those things that we talked about that Kubernetes does that allow us to run these containers inside of it. So you'll notice there, it's starting up the control plane. The control plane, again, going back to the slides, we had talked about that was the master node. That's the thing that keeps track of resources, delegates things, it handles all of that complex work so that all of our stuff can run very simply with very little effort. So we're starting up the control plane, and in a moment, you'll see a couple more things happen. And then the workers will also see joining worker nodes. So we're actually setting up our worker nodes right now. Now, I will show you guys in the cube files.
Yeah,
we're
maybe.
actually going to have our nodes defined here. And I could put a whole lot more worker nodes there if I wanted to. Right now, we're doing 2. Mainly, we're trying to manage our system resources in a way that's not going to make my laptop crash. Let's start on fire.
So does yours.
We're
Yeah, so there is a single worker. So the reason why we put 5 workers last week was really to have multiple nodes of Cassandra. It was a constraint from the operator. But hey, single worker is totally fine to have Cassandra and more stuff running in a single machine.
Absolutely. Now you'll notice it says you can now use your cluster with this command. And you'll notice that command is all listed out there. We also have it listed in the GitHub here. So we're just going to copy that over. And what we're doing is we're just setting up a context, nothing too crazy. You see there, it says Kubernetes master is here, kubedns is running over there. Basically, here's everything you need to actually interact with the cluster we just spun up.
Yeah, so question about, if you go back to the YAML, about the API server port. So that's just you telling kind to expose, the control plane API on this port. You choose which one. So we tend to use very large number, not ADAD, the one we tend to use. That's not random, that's fixed. But if you are running multiple kind, please remember to change the API server port because it will be bind.
Yes, that's an excellent point there. All right, so now we're going to go and we're going to create that first namespace. So again, this is the bucket that we're going to store all of our Cassandra in. So all the different pieces that need to run Cassandra live in this bucket. So we're just going to do kubectl create ns. Again, ns stands for namespace, and then cast operator, and we're going to go ahead and do that. Really, really quick. Takes no time at all. That's created. Then we're going to go and we're going to configure our storage class. And I will go into the storage class in just a second. I'm going to run the command here first.
Yeah, maybe you can make this terminal a bit bigger if you, just maybe hiding stuff on the right part. You know what? I will also jump on screen. So wait a minute. Okay, here I am. Now we can go.
Okay, hopefully that's a little better for everyone there. Awesome. All right. So
yeah, I'm close to the YAML. I'm good there.
Yeah, there you go. The storage class is right here. Basically, again, we're just defining what our storage class looks like for our Cassandra. Nothing too crazy, nothing out of the ordinary here. We got our provisioner, really, really simple stuff. Okay. Now we are going to go ahead and set up our Cassandra operator. So let's go do that. And that's done. And I will go into the YAML here really quick. This one is a whole lot longer. Reduce size there. This one is an incredibly long YAML file. I'm not going to go through it. There's no need to run through it all, but basically all of those individual things that I could change about my Cassandra, this is where you do that. This is where you go and dig in and actually make changes.
Yeah, maybe a word on that. You can see that in a single YAML file, you can create multiple resources. And look at the very top of the file, you are actually recreating the namespace. It's existing, so you will get just namespace already exists, and then you define others item, and you specify the namespace. So you probably don't have to add -n to provide the namespace there.
Yeah, totally correct. We do it just to be super explicit, but yeah, you don't necessarily need to there. Okay. Next, we're going to actually create our single node, and that's what I will walk into as well. Sorry, I'm going to keep expanding different windows and stuff just so you guys can see. I increased my font size. It is much larger than I normally work with, so windows are small. All right, so there we go. We got our node created, and that is actually not that crazy of a YAML. We have our DC defined. So remember, in Cassandra, a data center is a logical grouping of nodes, and you need to define that so that your node can know basically which one to live in. In one sense, you could kind of picture it as a data center is kind of like a namespace in Cassandra in some ways. There's a lot of similarity in how that grouping happens. So not exactly the same thing, but again, kind of a rough analogy. We have our storage. You see there that we're defining that. And then some Java heap settings and various other things.
Yeah, so you can override the default Cassandra.yaml to provide your own stuff.
Right. Right. All right. Next up, we're going to actually go, and I did a little bit of cooking show magic over here, and I have, you'll see here, I'm running this watch command, so the watch kubectl -n cast operator get pods. I'm running that, and right over here we can see that I have one, my cast operator is running.
Okay, now I'm again in front of the screen, so okay, let me go down. Yeah, boom. Okay.
You're going to be jumping back and forth a
lot. Okay, no problem.
So you might have noticed this just changed from 0 to 1 of 2, and we're going to wait a moment until that changes to 2 of 2 ready, which should take a couple seconds here, maybe a little bit longer than that. We'll see. I don't know if you guys can hear my fans spinning up on my Mac, but they just started whirring pretty.
Don't tell that. Small, small footprint today. It's still Cassandra.
Right, and technically we're running a whole other application on top of our Cassandra by the end of this, so it'll be fun. Let me scroll down here. You know what? I actually am going to talk about this real quick while that we're waiting for that to go. These are the Docker files. We showed them in the slides. These are the files that are in the repo. They're what we're going to use to build our images. They're also here if you just wanted to pick through them. Nothing too crazy in them again. It's just all basically the instructions for this is the environment we need, these are the dependencies we need, these are working directories and ports and all those things. We're just defining all of that and saying, go forth and do when we actually do the builds and then the runs. Okay. So, in a moment here, you know what? I can do this at the same time. It's totally fine because that will spin up while I am working on building out our app. So we'll come back and check that in a minute. I am going to do a Docker build on the UI image. You remember, over here, we have our UI folder, and I have this Docker file in the UI right here that defines its node, its version 12, working directories, does my npm install, my port, all of that. So I am going to come here, I'm going to change the directory, and then I'm going to run this Docker build, and notice that -t, I'm tagging the image as Astra UI : my image. Let's do that real quick, and boom! It's built. All right, and then we have to make a choice. I can go Java, or I can go Python for the back end. You don't really want to do both, and you're going to end up with some port conflicts if you were to try both out. Pick one to do, and just run with it. I'm going to do Python because I'm a Python guy, and I've done all my my personal practice with Python. I am not really that into Java, so we're going to let this run, and this will also take it a minute. Oh, wow, that was actually really fast. I might have said something cached there. Shh, don't tell anyone.
Oh, okay. I won't tell anybody.
Now, if you want to test this, I'm not going to do this part today because I've been through it a lot, and you can do this on your own if you want to verify that these things are indeed running, because essentially we just did that Docker build step, right? We took the Docker file, we created an image. If you want to do in Docker, create the container, you can actually go through and you can test and you can hit it on all the right ports, and it's fantastic. Just so I don't have to do any cleanup and mess with ports and mess with trying to unbind things, I'm going to skip that. And I'm going to jump down here to step 4C, where you see the kind load command. And again, I'm taking those tags that I defined in that earlier build step with Docker, and I am going to go ahead, actually, I'm going to do them both as a block, and I am just going to load those images into kind. Now, you'll notice there it says image, and it has the tag there with ID, not yet present on the node, loading. So it's going through, and this one actually does take about, it can take as much as 5-6 minutes to complete. Sometimes it's a little faster. It kind of depends on how busy my Mac is with other things. So we'll see. I've never tried this while streaming on a Skype before, so we'll see how long it actually takes. We can go back here and we'll notice, remember how I said we would see that this would become 2 of 2? It's done it. So our Cassandra is up and running. We are good to go there. And actually, what we can do while we are waiting for these images to load in my kind is I can actually go to another terminal and we can do some prep work for the next step. So, setting up our environment. This is most of what the hands-on portion is actually going to be today, is setting up the environment. So we're going to do this command right here, which is going to spit out a YAML file of our secret. The Cass operator is using, or the Cass operator is using a secret to, oops, sorry, I just got to have myself there, to store important config values. Now, you'll notice, remember that data tag, right? Right down here, data with a password and the username and their base64 and all of that loveliness. Well, for my cluster here, that is going to be my password. And what I'm going to do, again, a little bit of cooking show magic. I had this command sitting over here previously. I'm going to copy that value in. And again, the command I'm using is just this command right here. It's just I'm just taking the replace me, and I'm throwing that string into the replace me, and then I'm just going to run this command. So let me do that real quick here. Come over here and pasting that command, and remember, Cedric called it out, and I still fell for it. That
dash D.
And again, that is only because of the version of base64 that I am running locally on my machine. So
yeah, it worked with -D on my end. Yep.
Yep. A lot of you, it will work just fine. So then we have this. This is our actual password. It's our full decoded password. I could log into CQLSH, and I actually will in a little bit, using this password.
So you need to copy paste. Yep.
Yep. Copy paste. Exactly. So what I am going to do, and what you'll see in a moment here, instead of further step, I'm just going to go and instead of pasting it into a notepad file, I'm actually just going to go to my config map. I'm going to go to this value password, and I am going, oops, I don't want to paste the command. I did not copy it. I just highlighted it. So 1 second. I'm going to change me under password to that string. And now literally all that's done is when I go onto one of those Cassandra nodes, it will have an environmental variable that is password of that string, and it's going to use that when it logs in. The other thing we're going to need, and this is where some of the really cool stuff with services in Kubernetes comes in, is if I go down here and I run, okay, yeah, I'll just run the command and show you instead of talking about it. So I have my Kubernetes Cass what do we call it? The namespace. It was I believe Cass-operator. And it has some pods running. It has some stuff running in it. And here I can actually view what's running, and you'll notice cluster IP. Now, if I wanted to specify a direct IP address as a connection point, I could. However, because we have this nice service that we can reference that's running, I can, in my connection points, I can actually specify this essentially DNS name. It works to basically reference whatever IP is currently being used by the nodes of my Cassandra cluster. Whatever they have defined, it will go out, it knows that, and it will map that to the service. So I'm just going to put the service in there so that I can reference them even if they change. If I were to have a node go down and need to reprovision something and context point change, I don't have to go reconfigure everything. It'll just work. So that's why I'm doing it that way. And you'll notice that we've actually called that out. in the GitHub as well. It does work to go put a direct IP in. I will say that. But the moment a node goes down, you're going to need to do a whole lot of reconfiguration. So better to just start it right off that.
Eric, just a question. So I know you are using VS Code, but did you add any extension to make that workshop, or is it the default setting of VS Code?
Oh goodness, asking me if I've added extensions to VS Code is yes, I've added a lot of extensions.
Oh, okay. So you played a little bit.
Formatting. Yeah, they're all formatting. I try to not add anything in that would make it any different from a base install functionally speaking. Okay. Like there's no autocomplete stuff or any of that really going on. It's just also it does nice text highlighting in the right colors. So yeah, yours, depending on if you have a YAML extension or not, yours might just be all one solid color.
All right. Okay.
Yep. Okay. So let's go over to our other terminal and just see how it's doing real quick. You remember we were loading in. Okay, there's the UI. It's going still. This is taking a minute.
Again, I'm hiding the command. So let me go close to you today, up on top. I like moving here and there. Okay, so you are still loading the image. Yeah, so no surprise, you are uploading the image, which is multiple megabytes up to... Maybe you can do Docker images just after that to see what is the size of your,
oh yeah, absolutely.
After the load.
Yeah, and now we're loading the other one. So that one completed, and we're actually, since I did them as a block, we're on to the next one. This one should be a little bit faster. It's still going to take it a minute probably, but shouldn't take quite as long as that first one. So, okay. Let's see, do I want to go past that step? Yeah, we can load the schema while we wait. All right, so you remember I said we could actually, oh, wow, it just completed. Okay. Well, let's do that right now. You said, what command was I running? Docker images?
Yeah, Docker images.
Okay, and created size. We have Astra backend is 130 meg. And yeah, see, that's why it took so long. 1.11 gig for the Astra UI. So obviously took a little longer than the much smaller backend. And I think we're pulling a full, we're pulling a full install of Node in that there is an Alpine version of Node that you can pull in your Docker file if you want to. Alpine is kind of a minimal version, but you'll notice in there we're not defining like Alpine Node or I think it's actually Node : Alpine and the version number. We're just using straight up, give me the full Node install, go for it, which is part of why it takes so long there. All right. So now we're going to actually basically do the equivalent of SSHing into the node. And you'll notice there I did the kubectl exec -it-n cass operator, basically defining where is this. So it's the cass operator namespace, the actual thing I want to be going into there, and then of course bin bash. So I am now using a bash terminal like you would on any box. And what I'm going to do there is I'm just going to CQLSH. Remember, I said before we were going to CQLSH into this. I am going to do that, and I'm going to use username cluster superuser, or cluster1-superuser. Now, you'll notice I also have cluster1-superuser up here. And you'll notice that when I did that whole spitting out of that YAML and there's all that base64 encoding, I did not actually decode that. The reason I was able to do that is I know that that is what the cass operator uses as its default username. So we have that all pre-configured, just kind of, a little bit of hand-wavy magic, but I am going to need to copy my password there, and notice the -p, then my password. Hit enter on that, and I am in CQLSH. We have Cassandra running, guys. Yeah.
Good job.
All right. So now what we got to do is we got to take our schema, which I have here in the GitHub. I also actually have it at the root of week 6. We can open it up, and that whole schema file is there as well. Mm-hmm. Take it from whichever place you want. I'm just going to copy it out of the GitHub for.
So no surprise, this is the same schema we use week 3 and 4.
Yes, yes. All right, so I'm going to go ahead and paste that. And that's going to take a moment here while it goes through all of its steps. And we're done. Okay, and I'm actually going to leave this terminal open because I'm going to come back to it later. So I'm going to switch to my other terminal here, and we're going to keep on going. All right, so we have our schema loaded. We have our YAML. Our config YAML is now configured with our password, and it has our contact points, the service we're using. It's all should be good to go. We have our keyspace name there. In this case, I'm using what we've been using for the last few weeks, the Killer Video Keyspace. If you use something different and you wanted to set it up differently, you can obviously change that keyspace name. That's kind of up to you. And then of course use Astra false. Use Astra false being the thing that's saying no, we're not going to go out and use Astra. We are going to try and reference something locally. Okay, so now we get to go create that bucket for our own app. So we have the namespace, the CAS operator namespace, and now I'm going to create the my app case space. So kubectl create ns my app. So I'm going to go do that. Namespace created. Awesome. Then I'm not going to do this just yet because I want to actually show you these YAMLs. So we took a brief look at these. Essentially, this is the backend YAML. We're exposing some ports. We've got our image. And again, if we go back to the Docker images, the tagged image or the image tags are going to be exactly the same. And that's literally all of the referencing we're doing from end to end is done with these tags. So again, not optional. Make sure you tag things correctly and use it accordingly. Okay. So I'm going to go ahead and copy this. Let me make sure I'm in the right directory here because I don't believe I am on this terminal. I am not. So I'm going to cd into week 6. And I actually need to be in, yeah. Okay. And you saw what I did right there? It was so fast you might have missed it. I did 3 commands. And boom, my app is up and going. And what we can do is we can come over here and look at that. We got a backend running. We got a UI running. And the command I did to view that is basically just the watch on the kubectl-n my app get pods. Really, really simple. And our whole application, we've got our Cassandra up here. We've got our UI. We've got our backend. Last thing we've got to do is we've got to open up some ports so that it's actually accessible. I'm going to go ahead and I'm going to do that. And again, it's just a kubectl command to open up some ports. We have there we go, first one, and boom. All right, our ports are forwarded. Now, if we've done this all right, we should be able to go over to our UI here, and I'm actually going to refresh this because this is actually there from a previous run I did. So, so if it refreshes correctly, we will be good to go.
And so there are 2 backends. You can pick the one you like, but basically you only use one to do the demo.
Did I do the wrong password? Failed to authenticate, bad credentials. Did I not save my config map before I applied it? I will bet you that's the problem. Oh, fun.
Yeah, that's demo time. No big deal.
Yes, it is. All right, so I am actually going to need to go and remove that pod. Do I want to remove the whole namespace? Let's see, I need to get rid of the port binding, which is actually the harder of the problems here. I think I need to try to think of the quickest way to do it here. I might just destroy the whole Kubernetes cluster and rebuild it really quick, just so I don't have to untangle things. It'll take 2 seconds. So talk amongst yourselves. Give me a moment here. You'll notice we are getting all of the lost connection to pod, which you'd expect. I'm basically spinning everything down, and you'll notice over here, oh no, we have no connection to any of our stuff for our watch commands. That's because I literally just dropped a nuke. The whole thing's gone. Later. and I am going to do basically take advantage of the fact that Kubernetes is super easy to use. I'm going to go all the way up here, and there we are. All right, so I'm just going to copy these commands and run them one by one, preparing our nodes. And I'm not going to do any of the Docker build stuff, because if you remember, the Docker build stuff was running outside Kubernetes. So the only thing I nuked there was Kubernetes itself. I basically said, hey, everything you got running, just wipe it clean. But those Docker images still exist. I can show you that if you're curious in a second by just running a Docker images command here as soon as this is done, which will be a moment because I have to start the control plane. Now I am gonna have to reload those images because I essentially removed, again, in Kubernetes, I removed all of everything. So none of those bindings, none of those things we imported, none of it's there. All gone. Doing worker nodes, almost done there. We'll set our context as soon as that is up. Come on, we're almost there.
Oh, I just missed one part. Are you just creating everything all again?
Yeah. I figured instead of trying to go through the whole port thing, it'd be easy.
Yeah, I got the same question. Yeah, you know, you could have simply update the config and redeploy, I guess.
So actually not. Oops, I forgot the. I did have some issues with the ports staying bound in a bad state earlier, and that's purely a problem with me. It's not a problem with Kubernetes. But okay. And this is really easy to do. I mean, it is just a few commands. The hardest part is just going to be setting up the config file, but it's already set up, except for the password, which I'm going to need to repull. But again, that takes a moment to do. Okay, we got our Casa operator, and now if we come over here,
so now you need to wait for the pod to be there.
Yep. And there it is, it's spinning up. Okay, cool. That's going to be running, and I am going to go ahead and start the loading of my images, because that is what I'm going to need to take the time with. That's the longest step here. And notice I just skipped all the build stuff again, because I don't have to rebuild those. They're built. I just have to load those. Some background noise there.
Yeah, so during the time is loading and everything, so yeah, you could have simply updated the config map, redeploy the config map, and simply doing that, I'm pretty sure that the pod for the apps would have been restarted, because we did explicitly define a dependency between config map and the pod. So if you edit the config map, I expect the pod to restart.
Yeah, that's fair. Okay. So we are going to come over here, and probably isn't going to work because we're not fully up and running, but we're going to try it real quick because we want to, and hey, it did. Sweet. And I am going to go ahead, and I am going to take that command, and I'm going to get my password here.
Okay, so I'm taking the question about certification and Kubernetes and Docker. So as of now, no. The Kubernetes and Docker question are not part of the certification for developers. And for admins, they are being reworked. But I guess for you, it won't be there either. But, you know, before the end of the year, it will be there because that's the futures, as we told you. But no need for that for these certification coming in September.
Okay, and this is going. We should have the config map working. Perfect. Cassandra's almost back up. I'm going to run these last few commands here. I'm going to create my namespace. I'm going to reload my schema too. I forgot about that step. And that's not going to be happy with me because I didn't create my schema yet. Okay. And it was in the wrong folder.
All right.
That's all good.
And the password now.
Oops. That'll make me drag the character. There we go. Password. All right, and give it a moment, and we will be in ZQSH now. Try connecting. Connection refused. Are we not up yet? Oh, we're not up yet. Okay.
Yeah. So I bet people got this issue during the homework of week 5. Yeah, this is what happened when the pod is not 2/2 running. The service is not there. So by the way, 1/2. This is what in the Kubernetes world, this is called probes. So there are 2 probes, liveness and readiness. Liveness means your pod is starting, but the service is not there yet. And readiness, the service is ready to take response. And how Kubernetes just monitor is using some API available in the pod. And as no API is provided by Cassandra, at the class operator level, we added what we call a sidecar to expose an API for Kubernetes to monitor liveness and readiness of a Cassandra node.
Right. It'll take another moment or two, probably not very much longer. And this guy is loading still. Okay. Yeah, you're totally right. I could have probably just reapplied, but like I said, I did have some issues earlier, and I didn't want to.
Oh, no problem. I'm not judging.
If we're in production, that's definitely what I would have done. Whoa. My green screen just fell over. Yep, my green screen just totally fell off my chair. Give me a moment here. Awesome.
That's funny. Now you're half transparent. Totally funny.
Oh yeah, a little bit.
Oh, now all the magic about the episode just go down.
Yeah, we aren't really living in the computers, guys. Sorry, it's going to be, oh, that's blocking out some of the text. Okay, give me 1 second. I'm going to fix this.
Yes, your pod is still 1/2. For 6 minutes now, seems like quite long. Pay no attention to the man behind the screen. Yeah, you know what? Let me hide you. Yeah, nothing happened. Now I will stop moving because just people complain about me moving on screen.
All right, hopefully.
Yeah, I'm the guinea pig today. Yeah, just so comment here.
Okay.
So your pod is still 1/2. That's a bit weird.
Yeah, 6 minute thing. That is taking it a little while. Let's check this over here. And, okay, I know why it is. It is very, very slow because I am very low on system resources, so it's actually taking a while to load my my stuff as well.
But luckily, we do have time.
Oh yeah. I actually I spoke way too quickly early on, so I bought myself quite a bit of time here if we do need it. but hopefully, there we go. 2 of 2. We are good there. And I am going to come over here and I am going to rerun that, and that should get me into the CQL sh prompt. And again, yeah, this is running super slow, so just bear with me. We're going to copy in our schema. And there we go there. That's going to truck on through. Much slower than last time. Hopefully my laptop doesn't start on fire, because that would make this a very interesting stream for me. And a very dull stream for all of you. All right, so our schema is loaded. I'm going to leave that prompt up because I'm going to use it in a minute. Looks like our image loading is not quite done. Should be almost there.
Yeah.
In the meantime, we can actually go get our password and all that goodness. Actually, we already did that, so nope, we're good there. The config map, I'm going to make sure I actually save it this time. We are indeed saved. Amazing what a little Command S can do for the difference between something working and not. But okay. And this should take a minute or so, hopefully not more than a minute. And so we'll need to reapply cube files and reload my port. Yeah, or rebind my port. All right. Yeah, you guys are all getting to see how the sausage is made here.
Yeah.
All right, here we go. So now I'm going to apply all of those. If I come over here, I see my stuff is starting up. I'm going to bind my ports really quick. And there we go. Forwarding. That's good and that's good. And hopefully, if we've done it correctly, we should have, in a moment, once this actually loads. Hey!
Congratulations!
Take a note, people. Save your config files before you apply them. Okay, and we're going to reload the UI here just because it is a stale instance I have up. As we can see, everything is running. We've got 101 on all these, and then our Cassandra is running. I'm going to expand this just so that it formats nicely for now, but to show everyone can see it. Okay, and this is really taking it a moment, meaning we are probably at basically 100% CPU and RAM usage. Okay, I might just hard reload that actually. Tab. Okay, well, we'll give that a second instead. I'll cover this just while we're waiting for that to happen. To clean everything up at the end, you can actually do this. You can actually delete your namespaces and then delete your cluster. When you spin down any one of those things, like if I were to just do the command I did, which I just ran the delete cluster command, basically what it does is it wipes out everything, but just trying to do it as gracefully as possible. Delete your namespaces, it will spin down all the resources, it spins down everything associated, and then of course, deleting your cluster actually deletes the Kubernetes cluster. The other thing here, I'm going to do it slightly different than we're doing here. If you wanted to get test output from a journey, you would be able to run this command in your command line. Now, this is just a one-liner. I'm going to do all of these commands individually, but you will notice at the very end of this one, it has the change me. You'd put your password from before, the same one we put in the config map. You need to replace that change me with your password.
Yeah, so a couple of question because we do have time. So first about why did you redo all the steps? So again, we could have simply update the config map, deploy the config map, and so I think as there is a dependency between the pod and the config map, the pod is restarted by Kubernetes, or if not, just kill the pod and it will be respawned by Kubernetes. And yes, and also another question about port forwarding. If you can just show the command again, I think.
Absolutely. So the command is, I'm just going to show it over on the, there's the other one, right over here. So what we're doing, the ampersand at the end is not required. That just runs it in the background. The meat and potatoes of the command is this part right here, which literally all we're doing is we're saying port forward, again, namespace. We're specifying the namespace, port forward, pods. We're referencing the actual pod we've created there. We're saying port 3000 within that pod goes to 3000 externally. Really about as simple as you can get from a port forwarding standpoint. So, and then again, we're doing the same exact thing for the back end. Does that answer the question?
Yep, I think it does.
Awesome. All right, well, hopefully...
Just screening the question. Yeah, keep the question coming. So remember, after the 2-hour session, we will do Ask Me Anything session, just to get all the question ready, because we tend to have sometimes the same question and again. So if we can have them on video, would be nice.
Yeah, and this is really taking a moment. Let's see if it actually times out. Nope, it's going in. Okay. And that is purely because of low system resources. If you do this on a much bigger box, that will be very, very quick.
Also, you might notice that the UI has been updated. So now it does not ask about the secure clone bundle anymore, because it will simply invoke the backend, and the backend is directly connected to Cassandra.
Correct. So now I'm going to launch a journey, and that should run here. And this will take it a minute to do, but the insert was actually very quick. So we can actually already go and check that everything was inserted. So I'm going to come over here, and looks like we got kicked out. So I'm just going to have to reconnect. Authorization error, create the source proxy. Really? It does that sometimes when the system resources are inadequate. So probably since we're loading data, I'm going to give it a moment to finish that, and then I'll try it again. Yeah, on the instances we're spinning up for you all, that shouldn't be this slow. If you're doing it on a local laptop, highly recommend at least 16 gigs of RAM. That's what I'm running on, 16 gigs of RAM, and then an older i7. I think it's a 5th gen i7. And you can see how it's struggling. So you just make your choices in life accordingly. All right, let's try this again. Right, nope, still not. This is the authorization error too. Kind of funny. It's not actually an authorization error. It's that the authorization doesn't have enough resources to actually authorize me. But
yes, so 8 GB of RAM should be enough for today. So I think the Cassandra node need about 1 GB, and the application, both front end and back end, should also need altogether 1 GB, probably less. So yeah, I'm pretty sure that with 4 GB, I'm confident you can run this demo easily.
Yeah, I might be CPU bound too. I didn't actually check that. I should have probably checked that. But it is probably CPU. That's the bottleneck here.
Yeah. Oh, so we got again some question about certification. So I told before there were 2 certifications: developer and admin. And you know what? Just chatting with everyone, I see that we will give you the voucher for the dev, and if you succeed the dev, we also give you the voucher for admin. Okay.
Okay, we're going to do a quick describe just to make sure everything is where I think it is.
And no, Docker and Kubernetes are not part of the certification as of now. Next year it will.
Okay, yeah, so we're getting an unhealthy warning, basically. Liveliness probe failed. So our Cassandra overloaded and restarted. Default. Yeah, it looks like it's up. Kubernetes did that for me. Did I? Nope. I don't want this tripod. I want you authorization error. Okay. Cedric, do you have the expertise on this one? Because I can troubleshoot that, but that would probably take me too long.
Okay, readiness profile, defaulting container.
Yeah, it was a resource issue. We exploded resources and hit an unhealthy state. And then the kubelet restarted, I believe.
Okay.
The posture.
Don't talk to me. Authorization error, kube client, variables, create resource.
Yeah, and that is.
So can you do the get pods to see how is the pod going from the Java? Yep. Get pods.
And it's running.
Yeah, running. So there is no reason why the readiness probe would fail, except it just been running right now.
Yep, and it just. I could spin that down and back up again, I suppose. But we're already at system resource usage. What I'm trying to show you guys, just for reference here, is I'm trying to show you that the data actually made it into the and it did, but I don't want you to take my word for it.
Yeah, but you know, I didn't see the UI complaint or your backend complaint about just launching the journey. So
yeah, that all went through. I just want to show them the table itself and you know, make it an actual select. But yeah, it looks like we're gonna have to maybe do a little bit of troubleshooting on that.
Okay, so shoot again.
Or actually, yeah, no, that's working. Yeah, that's actually up here. So we actually are getting. Try it one more time, and then we'll just have to say, okay, you'll have to try it in your lab.
Yeah. Just say, looking at could describe to see all the container in this pod. Yeah, it should be. Yeah, you could try that to see the status of containers in the pod, but
yeah, which I mean,
what you did is just you try to bash and you get error when you try to bash.
Right.
In the container. All right.
Right.
And even then the pod is say running. That's pretty strange behavior.
Yeah. I've got a couple questions here in the YouTube chat. One of them is when you run git pods, you see the namespace running and the cluster. Don't they run in the same pod? No. So the namespace is the container that you put pods inside of. Let's see here. What else? Okay, yeah, that's the main one for us here. A couple certification ones. I think those are being addressed. Yeah, okay, cool. All right, well, given that that's the case, I'm going to go back to the slides. We're going to cover the rest, and then we'll move on.
Yeah.
All right. So, as I covered before, cleaning up is actually really easy.
I'm gaining form on everything. Okay. No, that's just... I'm just moving on screen again, so don't worry about that. Yeah, move on. Yep.
All right, so you basically just delete your namespaces, delete your cluster. If you were to just delete your cluster, it would go through and wipe out your namespaces anyway. But just so you guys can know the commands to do so. All right, wrapping up here. Homework. we are going to basically say everything you just saw, do it. Set up your app, set up your Cassandra, get it all running in Kubernetes. Again, everything is at the GitHub under week 6. Go check it out. The README is there. It's got all the instructions. If you follow the instructions, you should do it. Hopefully at this point, you guys understand what the different files have, why they're important, and how to configure some of them. Really did try to kind of deep dive on that for y'all. And
and so you can do the homework on your laptop. 4 GB of RAM in Docker should be enough this time. But yeah, I think 8 is totally comfortable. And below the video, there is a form to request a cloud instance for you to do stuff. Kind is already installed. The instance will last 24 hours by default. But you can extend a little bit these by typing the command extend. I think you can do that 3 days. Okay, but we cannot make 1,000 instances running during 1 week. So we will run what you expect, and anybody don't hit extend command will get the instance terminated. Yeah, simply.
Awesome. Yeah. All right, and then next thing. Do you want to talk about this one?
Yeah, just a reminder about the Astracathon that is going. We didn't get a lot of submission yet, so remember the end date is August 20th, so you still have plenty of time. We are here to answer your question even before submission, and just also remind everybody that we will do a huge Ask Me, Ask You Anything session, like week 9. The 1 week after the series, just to announce who are the winners and just answer any of the questions, and also announce what content we could make during the next season.
Yeah, awesome.